Okay, so the next topic in physics that we're going to be studying is all about energy. We just finished learning about forces and about speed and velocity, and we did some mathematics, and this next topic is going to be about energy. I want you to write these notes on page 15 in your notebook, and if you want to, you can kind of divide the page up into some sections. I'm thinking maybe 7 sections. That sounds like an odd number, but we're going to be talking about 7 specific forms of energy, and so that might be a way to organize your notes. But it's entirely up to you. If you want to just do Cornell style, that's fine too. So the first thing let's talk about is exactly what energy is, and there's a scientific definition of it. It's kind of weird to think about having a scientific definition of a word that's common like energy, but energy is defined scientifically as the ability to do work. So if something does work, it has used energy. And there's a scientific definition of work too, but we're not going to get into that in this particular class. You'll probably learn about that in high school. But the ability to do work means that something's happened, something's been done, something's moved, something's lifted. It's pretty much any kind of activity that we can see, that we can experience in the world. It's going to need energy to be involved. There are 7 forms of energy that we're going to talk about, and we're going to talk about each one briefly before we move on to another topic. But these are the 7 main forms of energy. They are mechanical, sound energy, thermal energy, electric energy or electrical energy, radiant energy, nuclear, and chemical energy. And now we're going to talk about each one at a time. So the first form of energy we'll talk about is mechanical energy. Mechanical energy is the energy of an object based on its position or its motion. So this really has to do a lot of times with moving objects. This type of energy is acquired, or objects receive that energy whenever work is done. We also sometimes talk about mechanical energy as the total energy of a system. But whenever you do something like throw a basketball, hammer a nail, roll a bowling ball, all of these are involved with mechanical energy. Those are examples. The second form of energy is sound energy, and sound energy is the energy of vibrating objects. Later in the semester we're going to talk more specifically about sound waves, but they are vibrations. That's what sound is. And so the energy contained in those vibrating objects or vibrating molecules, vibrating atoms, we call that sound energy. And I don't know if you've ever seen the old commercial where the glass was broken by the speaker, or sometimes they say people singing can break a glass, and that just gives you an idea of the energy contained within sound. You really can break glass with sound. The third form of energy is thermal energy. The other way of thinking about this word thermal is it is heat. And we'll talk quite a bit about thermal energy here in a couple of weeks. Remember, we're going to be making ice cream, and that involves moving heat. So thermal energy is the energy in the motion of the particles in a substance. So actually heat is moving particles. So when you talk about like atoms or molecules that make up a substance, how much they're moving is the amount of thermal energy that they have. And remember, thermal energy can be created by friction. So a moving object can create thermal energy, or not really create thermal energy, but thermal energy can be created through that process. The fourth form of energy is electrical energy or electric energy, and this is the energy that's carried in an electric current, and an electric current is actually moving electrons. So electrons that are flowing in a current in a wire or some other object, we call this electrical energy, and of course it's extremely useful in our everyday life. The fifth form of energy is radiant energy. We also call it light. So light is a form of energy. Of course, it travels to Earth from the sun in waves that are called electromagnetic waves. Later on, probably when you're in high school, you'll learn about why they're called that. But for now, you just need to know that they're electromagnetic waves. They include light that we're familiar with, but radiant energy also includes some waves that you may not realize are coming from the sun, and that's microwaves, X-rays, gamma rays, radio waves. All of those are forms of radiant energy. The sixth form of energy is nuclear energy, and this is the energy that's stored in the nucleus of an atom. So we talked before about the structure of an atom and how the nucleus had protons and neutrons, and then outside of the nucleus were the electrons zooming around. Well, there are very strong forces that hold that nucleus together, that hold the protons and neutrons together tightly, and if you try to break it apart, break the nucleus apart, there is a ton of energy released because of those forces. And of course, breaking apart an atom like that, breaking apart the nucleus of an atom, we call that a nuclear bomb, really, breaking apart atoms. And of course, we use it for a form of energy that we use in our homes as well. We call it nuclear power. So that's one of the 7 forms of energy. The final and seventh and final form of energy that we're going to talk about is chemical energy. And this is the energy that's stored in chemical bonds between atoms. So nuclear energy is the energy stored within one atom in the nucleus. Chemical energy is when you're taking atoms and you're bonding them together to form compounds, more complex compounds like water or sugar. And those bonds that hold them together, again, it's a type of force, and when you break that bond, then energy is released. So, for instance, this diagram here is reminding you about photosynthesis. And I know that I've reminded you about it before, and you learned about it in life science class. But the sun's energy is converted in a plant through the process of photosynthesis, and the plant makes sugars. And sugars store up chemical energy in those bonds that are formed between the carbons and the oxygens and the hydrogens that make up the sugar. And then we can actually consume the sugar, and when we break it down, that energy is released, and that gives us energy for our body. So that's stored chemical energy in sugars in the plant. All the foods we eat have chemical energy, and of course fruit is just one example. Now, think to yourself if you can match these different items with the type of energy that they contain. Go ahead and pause the video and then check your answers. A mug of coffee contains thermal energy. A piece of coal contains chemical energy because it's a fuel. An orchestra is using sound energy, and that leaves a moving bicycle having mechanical energy. How did you do? Now, so far we've been talking about the 7 forms of chemical energy, of energy. And now I want to talk about the states of energy, which may be a little confusing at first, but I'm hoping I can explain it to you. So there's 2 main energy states, and each of the 7 forms of energy can be in one or the other of those states. So the 2 states of energy are potential and kinetic energy. And I usually abbreviate those PE and KE, so you're going to see me in class abbreviating those all the time. But any form that you have is going to be one of these 2 states, either potential energy or kinetic energy. Kinetic energy is the energy of motion, and potential energy is stored energy. Okay, so these are the key words that you really need to focus in on when you're understanding those. Kinetic energy has to do with anything that's moving. It's the energy of motion. Potential energy is energy that's being stored and can be released and used later. So as I said, each of the 7 forms of energy we just discussed can be thought of as either potential energy, kinetic energy, or sometimes a combination. For instance, kinetic energy, electrical, can be thought of as that. Light or radiant energy can be thought of as kinetic. Thermal energy is kinetic energy. Sound energy is kinetic energy. And then for potential energy, chemical energy that we talked about is potential energy, and nuclear energy is potential energy. And then, of course, they show electrical here, which electrical, I imagine, could be a combination of the two. And what's not listed here is mechanical energy, which is a combination of the two. Now, I just want to give you a little word about kinetic energy. When you talk about kinetic energy, two things affect the amount of kinetic energy an object has. If it's moving faster, it has more kinetic energy. And if it's bigger, if it has more mass, it has more kinetic energy. Okay, so this engine, this fire engine, will have more kinetic energy than this little compact car because it's larger. As I said a minute ago, potential energy, of course, is stored energy. It can be stored chemically in fuel, foods, or in an atom, or it can be stored because work has been done on it. For instance, you can stretch a rubber band and it's storing up the energy. When you release the rubber band, it lets the energy go. And you know what that means because, of course, you probably have shot a rubber band at somebody before. You pull back on a bow to shoot an arrow. When you're pulling back the bow, you do work on the bow and you're storing up that energy. Then when you let go, it releases that energy, and that gives the arrow its energy to move forward. So it gets transformed into kinetic energy at that point. And then, of course, lifting something up, like I just put on there, lifting a brick. If you're lifting something up, you lift it up, it has the potential to fall, and as it falls, it's giving off that energy. Now, there are three types of potential energy. As I said, this is stored energy. There's gravitational potential energy, and gravitational potential energy is the energy of any object that's been lifted up, like an airplane or a brick or a waterfall. Any object that's been lifted up, it has the potential to fall, and as it falls, it's going to be experiencing some kinetic energy. So it has stored energy just simply because it's been lifted up. Secondly, elastic potential energy is energy that's been stored in some object because it's been it's been morphed, it's been transformed in its shape. So a spring is one example. You squeeze the spring and let it go, and it stores the energy when you squeeze it. Or like the rubber band, you stretch the rubber band and you're storing up the energy. And then finally, the third type of potential energy is chemical potential energy, and that's the energy that's stored in chemical bonds. We talked about food and fuel already. Another example, of course, the chemicals that are in a battery are storing up energy within the battery, and then we can use it later to run our electronic devices or whatever we're using batteries for, flashlight, something like that. Okay, I know I've been covering a lot of material, so you might have to kind of pause it and go back and really listen. This is kind of a long lesson, but we'll go over a lot of this in class as well. I have two more things one more thing with two parts that I want to discuss with you, and that is a scientific law having to do with energy. It's the law of conservation of energy. And remember what a scientific law is. This is something that it is true. It's true all the time. Okay, it's not explaining, it's just telling what is true in nature. And so the law of conservation of energy has two parts. The first part says that energy cannot be created or destroyed. It can only be converted. Okay, so we cannot make energy and we cannot destroy energy. All the energy that was is, and all that happens is it gets converted. So you can't make energy, even though we talk about it like we are making energy. We really aren't. All we're doing is transforming the energy. Okay, last but not least, and this is going to be the end of the lesson, the second part of the law of conservation of energy says that whenever you do transform energy, some of it is always converted to thermal energy or heat. Okay, and this usually is because of friction. Whenever you're you have moving parts or something like that, there's always some friction, there's some heat generated due to the friction. All right, we're going to talk about all this stuff in class. I hope this wasn't too much for you, and I'll see you later. Thanks for listening.
Made with Doodlecast Pro.